Assalamualaikum and hi. My name is RAHMAN bin HUSIN AKASSIM. My number matric is S60861. In today's video, we will have a look at solid-state induction motor drive. So, firstly, what is induction motor? Induction motor is a constant speed and self-starting alternating current motor. It is known as constant speed motor because mostly its speed is constant rely on the frequency of the input supply and number of windings of the motor. Nowadays, the most used technique for the speed regulation of the induction motor is the solid-state variable frequency induction motor drive. You can see in the given figure a solid-state driver for induction motor. The flexibility of this drive is very high. It can be connected with the one-phase or three-phase supply. It can also connect with the system that has frequency either 50 or 60 Hz. And it can also operate on the voltage range from 208 to 230 volts. The output of this solid-state drive is three-phase and its frequency can be changed from 0 to 120 Hz and its output voltage can be 0 to the rated voltage of the motor. The output voltage and frequency of this drive can be varied by using the PWM, that is, pulse width modulation. The output voltage of the solid-state drive and output frequency can be varied autonomously with the PWM. In the given figure, you can see that the pulse width modulation is controlling the output frequency by keeping the root mean square, that is RMS, voltage at a constant level. In this given figure, we can see that the pulse width modulation varying the root mean square voltage by keeping output frequency at a constant level. It is frequently required to change the output frequency and output root mean square voltage together in a linear way. The given diagram explains the output voltage wave for a single phase of the drive in case when the voltage and frequency are both varying currently in a linear style. The frequency at the output of the solid-state drive can be varied from button manufactured on the body of the drive, or from a long distance it can be regulated by outer current or voltage signal. The capability to regulate the frequency of the drive by any rotor signal has importance because it allows any exterior process monitor or computer to adjust the speed of the induction motor according to the need of the system with the motor is connected. When the required speed of the motor varies, any motor drive that regulating the speed will vary the frequency to maintain the motor speed. If the speed variation is abrupt, like it varies from 900 to 1200 revolutions per minute, the drive does not attempt to force the motor promptly jump from the older required speed to the newer required speed. In its place, the rate with that motor is accelerating or decelerating is restricted to a safe point by distinct circuit constructed into the electronic part of the drive. These rates can be varied independently for acceleration and deceleration. For induction motor protection, the drive of the induction motor have lots of specifications for the protection of the motor that is attached to it. The motor's drive can send extreme steady-state currents during overloading of the motor, extreme instantaneous currents, over voltage, or under voltage disorder. If any fault occurs, the explained drive will disconnect the power supply of the motor. That's all from me about the induction motor. Thank you.